Hi everyone, welcome to this video session. I'm Dr. Lily Florence, Professor Department of CSE, Ariman College of Engineering, Hosur. In this video, I'm going to brief about machine learning. These are the content of my presentation, that is learning or machine learning, types of machine learning, applications of machine learning. What is learning? So learning, as you all know that learning will be from past experience, or learning will be from previous data, or learning from some books. So machine learning can be defined as learn from experience E with respect to some class of task T and performance measure P. So here we can learn some task from past experience. How long we can learn the process or learn the task until we reach our performance measure. So three components are very important for machine learning. One is the experience, and second one is the task. For what task or for what purpose we are going to learn. And the next one, how long the learning will perform. So until we reach our target performance, till then we will learn this. So this is the definition of machine learning given by Tom Mitchell, the professor at Cornell Mellon University. An example has been given here. Consider the problem of recognizing handwritten digits. So in handwritten digits classification, the task is classifying handwritten digits from images. So set of images has been given. So that is nothing but your data set, or that is nothing but your experience E. So from that data set, we have to learn the digits from the images. So if I have given some digit 9 in the image, so 9 will be looking like this. So this learning can be performed using the given training set. So how long we can learn the percentage of digit classified correctly? So I can fix my target performance 95% if it is classifying the digits correctly. Then I can stop my learning process. So these are the three components of machine learning. How do you differentiate traditional computer programming and the machine learning? If you are talking about computer programming, we have to write a set of instructions, and we have to compile the program, execute the program with the sample input, and we will get some set of output. Then we will verify for a given input, the output is correct. If it is okay, then our program is perfectly working. When you come to machine learning, here we are not going to write any set of instructions. Here we have set of data, and set of, for the data, the corresponding answers will be there. Both we have to give for the learning process. So in the learning process, it will tune the data with answers, and it will create set of rules for us, so that rules can be applied to new set of data. So this is the process we are taking in machine learning. So in machine learning, we are not directly writing set of code. We will give some set of experience or data set with a set of answers. We have to frame the rules here. That is the major difference between traditional programming and machine learning. Now, how do you classify the machine learning? So machine learning can be broadly classified into three types: supervised learning, unsupervised learning, and reinforcement learning. So this classification is mainly based on what type of data set we are using and what type of operations we are performing. So based on that, these three classifications. When you take supervised learning, the supervised learning, this is a type of machine learning in which the machines are trained using labeled data set. So here we have set of data along with the answers will be there. That is called labeled data. So based on the data and answer, we have to perform the learning here. So always there is a supervision in the learning process. For given data set, are you getting the answer? That is, suppose you want to classify the data set of students into male and female. So we have set of data and the gender will also be there. This is nothing but labeled data. Or if you are classifying the plant diseases, whether it is a poisonous plant or not poisonous, so we have set of features. Along with the features, we have yes or no. The targeted class label will be there. Such type of learning is called supervised learning. So here there will be a mapping function which will map the input data with the output variable. So this is supervised learning here. Unsupervised learning, this is a unlabeled data we will have. So we do not have any answers here. We have only raw data set. That data set has to be trained and we will create some set of patterns out of the data set. So this is supervised learning and unsupervised learning. The next one, reinforcement learning. Here we are performing the learning based on the real-time data set. So here mostly this learning is based on the decision making. So if a robot is moving on a plane, and when it reaches the edge of the plane, it has to take decision whether to move left or right. So here, based on the real-time data, it has to take a decision about its movement. So such type of learning is called as reinforcement learning. Robo movement or online games, everywhere we are using reinforcement learning. Now, how do you compare supervised and unsupervised learning? So when you talk about supervised learning, the input data is labeled data. As in the previous slide I explained, the data will be with the input and output will be there. But in unsupervised, we will use only the raw data. It is unlabeled data. So in supervised, we are using training data set. Yes, of course, the training data set, we have a set of data along with answers. So we have to frame the rules. But in unsupervised learning, just raw data we will use. We will not have any targeted output, or we will not have any target labeled output here. The operations we can perform in supervised learning is classification and predictions we can do. When you come to supervised learning, the operations performed here is clustering and association analysis we can perform here. So these are the major difference between supervised learning and unsupervised learning here. Now, what are different operations we can perform under different learning types? So when you take supervised learning, as you all know that supervised learning is otherwise called labeled data set learning. So the data will be labeled. So here we can perform two types of operations, classification and regression. If your data set having categorical data, that is your target output is a categorical data, yes, no, positive, negative, true, false, such type of categorization, we will go with classification techniques, classification operations we can perform. Or if your targeted output is in continuous values like 0.79, or if you want to find a person with 15 years of experience, what will be his salary? So here, these are all continuous values data. So for such type of data, we will go up with regression operations. So under supervised learning, we can perform classification and regression. So some of the applications in the next coming slides, let me discuss. Coming to unsupervised learning, here we will perform two operations. One is dimensionality reduction and another one is cluster. Dimensionality reductions mainly based on, we will use for text mining, image compressions, video analysis. For such type of data set, we will go up with dimensionality reduction. So why we are using dimensionality reduction means, if your data set has very large dimensions, so suppose you are using the data as it is, you will get a curse of dimensionality. So to avoid curse of dimensionality, we will perform dimensionality reduction operation. And another operation we will perform here is clustering. We will perform. Clustering is nothing but grouping the data. Since in unsupervised learning, our data set will not have target class or it is unlabeled class. So we cannot perform like a classification regressions. We can group the data based on some properties. Like suppose I have given a basket of fruits like apple, mango, banana, like that. A collection of fruits has been given and asked me to group the fruits. So how do I perform this? Since based on the length or based on the color or based on the size, we can perform the clustering. So these are the operations we can perform with unsupervised learning. When you come to reinforcement learning, all these operations we will perform their classifications, regressions, dimensionality reduction, clustering, but the data set will be a real-time data set we will use. These are some of the operations we can perform in types of machine learning. These are some of the applications we are using machine learning technique for our day-to-day life as email spam detections. So when you open our email, some mails will be in inbox and some mails will be in spam. So here it will detect the spam and it will classify the mails into inbox mail and a spam mail. And next to face detections, everywhere in biometrics, we are using face detection, fingerprint detection. So here we are classifying and we are detecting the objects. Web search, we are using sports predictions. We can predict which match, which is the team will win the match, such type of predictions. Stock predictions we can do. Credit card fraudulent detections. Credit card fraudulent detections and all, we will call this as outlier analysis. So using outlier analysis, we can find credit card fraudulence. Smart assistance, and then product recommendations. So product recommendation is coming under clustering on unsupervised learning. So association analysis, we will analyze association among products. So the people who are buying computer, they may buy printer, or people who are buying computer, they may buy Wi-Fi assistance. So this is we are finding association among product, and when the people are trying to buy some product, the system will recommend, when you buy this, you can get, or sometimes during festival offers, they will give. So this is association analysis. Next is self-driving cars. So in self-driving cars, we are using deep learning. See, we have to identify the objects on the road. So when a car is moving on the road, so left side and right side, what are the objects? Accordingly, the car has to drive automatically. So next, language translation. So natural language processing techniques will be used for language translation. Sentiment analysis, here we will take data from social media like Facebook, Twitter, WhatsApp. So using this data, we will analyze the sentiment of the people, how they are judging. See, something happened in the political world, so people will talk about that news. So we can analyze such type of news using social media data set. And then in biological field also, we are using machine learning techniques. So these are some of the applications where we can use machine learning techniques. What are different challenges we are facing to train or to learn the model? So the very first one is inadequate training data. So we need enough training data so that we can perform the learning correctly and we can get the better performance. So we need adequate training data. And a very important one is the quality of data, because the output is based on the quality input. If the input is not a quality one, we cannot get a quality output. So how do we make the quality data from your raw data? Means we will perform pre-processing steps like data integrations, avoid the missing data, filling the missing data, transformations. That is, we have to transform the data in a uniform scaling. Such type of techniques we will apply before getting to the learning process. And non-representative training data, that is, sometimes the data will not be represent a particular domain. So we have to perform the conversion methods here. We have to apply certain, that is, auto-encoding methods we can use here to convert the data. And the very important one is overfitting and underfitting. Some learning will perform good in training time and will not perform in testing time. So when we train the data, we will find the performance 99%. But when you try to test the data with that, we will get only 50%. That is overfitting or underfitting. It will not perform well in the training, but it will perform in testing data. So such type of challenges will be there in the machine learning, and monitoring and maintenance is very difficult since it will react based on the data, then lack of skilled resources. These are some of the challenges we are facing when you train the machine learning models. Where can you take the data set? We have a lot of data set in the internet. Some free resources are there to download data set and to learn the machine learning models. So these are some of the e-resources where you can find your data set. So in this video, I have given a definition of machine learning, types of machine learning, and applications of machine learning. Thank you. Thank you